All right, let's stop estimating and let's start actually find the actual derivative. So this learning target is you're going to be able to find the derivative of a function using the definition of a derivative. And hopefully when we get to this, it will look a little familiar. The most common way to show that we want a derivative is to write the function like normal and then put a little apostrophe between the f and the x. Now they could also do it like this. This is saying the derivative of h with respect to x. Or they could write dy dx. So if they say dy dx, that is saying the derivative of y's function with respect to x. And what it means, sometimes people don't really understand what with respect to x means. It means that y is on the left side of the equal sign, and the only variable on the right side is x, or a combination of different x's. So in other words, you couldn't have the letter t in an equation that says the derivative of y with respect to x. Y prime, so they can kind of leave out the of x if they want to. So there's a lot of different variations, but basically these all mean the same thing, means find the derivative. All right, let's talk about this derivative function. So last chapter, actually we could kind of go back even further. In our prereq chapter, we just had some problems where we had to plug in x plus delta x minus f of x. So we did all of this without the limit, without the delta x on the bottom. And then the previous chapter we brought in the limit, because that's when we started talking about limits. And then our answer was like some functions. This whole process of doing all the mathematics, and then at the end throwing in 0 for delta x. Remember, we're approaching a value of 0, whether we get there or not. And then us getting an actual final answer, that means this, which means that when we take the limit is delta x approaches 0 of the functions x plus delta x, which means x, the original problem, plus some change, minus the original problem, and then divided all that by delta x, whatever we get for our answer, that's going to be called the derivative. And then we're going to delve further into what derivatives really mean and what they do for us and how they can help us with other problems to come. But we're just going to start with the whole derivative process now. So on these examples, it says find the derivative using the definition. Well, let me just write down the definition again. The limit as delta x approaches 0 of x plus delta x minus the original function is actually going to be the derivative. So it says, let's get going. So now here's my original function. You have to make sure you put this at the beginning now. I need to take the limit as delta x approaches 0. And then what I'm going to do is I'm going to plug in x plus delta x wherever there's an x. So if you remember back in the day, I used to kind of do this. Minus the original function. All over delta x. So what am I going to put in its place? I'm going to replace it with x plus delta x. And now I'm going to do the math. So 1 minus x plus delta x is just like x plus delta x times x plus delta x. Remember, that's what it means to square something. Didn't leave myself enough room here. Minus, now I have to subtract both of these. Okay, so this 1 will cancel with this negative 1. Negative x squared with positive x squared. And I'm left with negative 2x delta x minus delta x all squared, all being divided by delta x, Remember, I can pull out a delta x in my numerator. And what I usually do is, because these right here are both negative, I would actually just pull out a negative delta x. It doesn't really matter. And those cancel. Now, last chapter, remember we learned how to plug now. We actually have to do this section of it. Now, wherever there's a delta x, plug a 0 in. So this right here will become 0. And so the derivative of 1 minus x squared, the original problem, is going to be negative 2x. Now let's think of that visually. Again, I'm a visual teacher. This graph is a parabola. It's an upside down parabola starting at 1. Vertex is at 1. So it looks something like this. So then the derivative is going to be a straight line with a negative 2x function, which then looks like this. And this all goes along with units. Okay, or thinks about this. If this is a squared function, its derivative is a linear function. We go down a level with exponents. And that's going to come in a lot more handy later on in the chapter. All right, let's do one more here, using the definition of the derivative. So, the limit as delta x approaches 0, and again, you have to have that in there, otherwise nothing will work out. And then what I'm going to do is I'm going to take this entire function, but wherever there's an x, I'm just going to leave an open spot. And then I'm going to subtract the original function, and all of it goes over delta x. Okay, what goes in this empty spot is x plus delta x. Now I'm just going to go through and distribute. Now I'm going to simplify. Cancel, 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 cancel. And I'm left with 3 delta x all over delta x. Well, those cancel, and I'm left with 3. So now remember, if I take the limit as delta x approaches 0, what I'm saying is plug a 0 in wherever any delta x occurs. Well, there is no delta x. So the limit is just 3. I don't need to plug anything in. Which means that the derivative of my original function way up here is just 3. Okay, let's talk about that visually again. Okay, I'm kind of just giving you foreshadowing later on in other chapters here. If this original function is linear, exponents 1, it's going to be a straight line, right? Linear is a straight line. Its derivative is a horizontal line. This is the same thing as saying y is equal to 3. So over here, when I start out with a squared, my derivative has an exponent of 1. I went from a 2 to a 1. This time I'm going to start with an exponent of 1, and I'm going to go to an exponent of nothing. I went from an exponent of 1 to an exponent of 0. Notice I'm going down when I take the derivative in my exponents. Well, let's take a look at this problem. It's still talking about derivatives and such, but it's worded a little funnier, so we need to be able to answer this type of problem. So it says, find the slope of the tangent line at that particular point. Here's a sketch at the point 2, negative 3. What I'm saying is, okay, here's a tangent line going through the point 2, negative 3. Find the slope at that particular spot, not just any old spot. I don't care about, this tangent line or this tangent line or this tangent line. At this particular spot, find the slope. So now when I find the derivative, using the only way I know so far, the definition of the derivative. Now, just for note-taking purposes, we're going to make this a little easy in here. We already found the derivative of this. Go back. Another problem. It's right here. See it? So we know the derivative is negative 2x. We've already done all that. All right, so I can write y prime is equal to negative 2x. I can write f prime x equals negative 2x. Remember, there's all those different notations at the beginning, but they all mean the same thing. So now what I'm saying is, don't just give me a function for the derivative. I want to know at a particular point. So now what I'm going to do is I'm going to plug in this x value right here in for my x here. So the derivative at the point 2 is going to be negative 4. All right, let's look at this one. This one's a little bit more complicated just because of the whole square root business. But I want you to find the derivative using the definition. So again, the derivative is the limit as delta x approaches 0. I'm just rewriting these from previous slides. You probably already have it if you're in your notes if you're looking. All right, so I'm going to take the limit as delta x approaches 0 of wherever there's an x. I'm going to put something else in its place in a few minutes. And then I'm going to subtract the original function. Okay, so what do I put here in its spot? I put in the x plus delta x. All right, so here's my problem. I have x plus delta x minus 4 minus square root of x minus 4 all over delta x. And I want to be able to plug a 0 wherever there's a delta x, which I can't because my denominator is 0. So I have to rationalize this. I'll give you a minute to write this down in just a second. Just pause the video. So when I go to multiply, I'm going to multiply this times this, which just gets rid of the square root. And then a negative sign times a positive sign is going to give me a negative. But since there's more than just one thing after that, I need to remember to put parentheses around it. The square root of x minus 4 times the square root of x minus 4 is just x minus 4. Remember, your directions were to never distribute the denominator. So I just have to finish this numerator. So that gives me this. These cancel. These cancel. So right now what I have is I have just a plain old delta x in the numerator. I have this delta x for my denominator. Then I still have this whole binomial right here. Okay, these cancel. Okay, so I'm just done doing the math here. So now I need to go back up. Remember here, originally I was asked to take the limit as delta x approaches 0. So plug a 0 now in for all your delta x. So now I'm going to get 1 over square root of x minus 4 plus the square root of x minus 4. Remember, these are like terms, so the square root of x minus 4 plus the square root of x minus 4 is just 2 of those. 2 times the square root of x minus 4. And so my final answer, boom, last chapter I would circle it, but what does that mean now in this chapter? We're saying that the derivative is 1 over 2 times the square root of x minus 4. Ooh, there you go.